For tens of thousands of years, humans survived some of the coldest climates ever experienced on Earth. Long before electricity, insulated buildings, or modern heating systems existed, entire families lived through winters that lasted months, with temperatures falling far below freezing. In places where a modern human would struggle to survive for even a few hours without protection, early humans built shelters, preserved food, raised children, and created art. Their survival was not based on luck. It was the result of careful planning, deep environmental knowledge, and surprisingly advanced engineering principles. During the last ice age, large parts of Europe and Asia were locked in extreme cold. Wind swept across open plains, snow covered the ground for most of the year, and fuel sources were scarce. Yet archaeological evidence shows that humans did not simply hide in caves and wait for winter to pass. Instead, they engineered living spaces designed specifically for long-term survival in harsh environments. One of the most important discoveries made by early humans was the insulating power of the ground itself. Soil holds heat far better than open air, especially below the frost line. By digging shelters partially underground, people were able to take advantage of stable temperatures beneath the surface. These semi-subterranean homes reduced heat loss, blocked wind, and required far less fuel to keep warm. Excavations across northern Eurasia reveal circular or oval depressions dug several feet into the earth. These were not random holes, but carefully measured foundations. The depth was chosen deliberately to balance insulation with structural stability. Walls were reinforced using packed earth, stone, and organic materials, creating a natural barrier against extreme cold. Above ground, early humans developed layered wall systems that functioned much like modern insulation. Animal hides were often used as an inner layer, with fur facing inward to trap warm air. Outside of this, dried grasses, moss, and reeds added insulation while helping control moisture. The outermost layers acted as windbreaks, preventing cold air from stripping heat away from the shelter. In regions where large animals like mammoths roamed, humans adapted their building techniques even further. Some of the most remarkable Ice Age shelters were constructed using mammoth bones. These massive structures were not temporary camps, but carefully designed homes meant to last through entire winters. Large bones formed the framework, while smaller bones filled gaps and strengthened the walls. Thick hides were stretched over the structure, creating a sealed interior that retained heat efficiently. Heating these shelters required careful control. Fire was essential, but uncontrolled smoke and moisture could make enclosed spaces dangerous. Early humans solved this problem through ventilation. Small air openings were positioned near the ground to allow fresh air to enter, while openings near the roof allowed smoke and warm, moist air to escape. This created natural airflow without losing too much heat. Fuel management was equally important. In treeless environments, wood was scarce or unavailable. Instead, people used alternative fuels such as dried animal dung, bones, and grasses. These materials burned slowly and produced steady heat. Archaeological remains show that fuel was often prepared in advance, dried and stored to ensure reliable heating throughout the winter. Survival in extreme cold also depended on food storage. Ice Age humans understood that winter was not the time to hunt large quantities of food. Instead, they relied on preservation techniques developed during warmer months. Meat was frozen naturally in permafrost, stored in underground pits, or dried and smoked. These storage methods allowed families to survive long periods without fresh kills. Shelters were not just places to sleep, they were organized living spaces designed for efficiency and comfort. Central hearths provided warmth and light, while specific areas were used for tool making, food preparation, and rest.
The warmest spots were often reserved for children and the elderly, showing an understanding of vulnerability and care within the group. Long winters forced people to remain indoors for extended periods, which required attention to mental well-being as well as physical survival. Evidence of art, carved objects, and decorative tools found in winter shelters suggested that creativity played an important role. These activities helped maintain social bonds and provided structure during months of isolation. The construction of winter shelters followed a strict seasonal schedule. Building typically began in late summer or early autumn before freezing temperatures made outdoor work dangerous. Experimental archaeology shows that a small group of adults could construct a complete winter shelter in a few weeks, provided materials were prepared in advance. Maintenance continued throughout the winter, with damaged insulation replaced and structural elements reinforced as needed. When spring arrived, many shelters were deliberately dismantled. Valuable materials, such as hides, tools, and portable components were recovered and reused the following year. In some cases, frameworks were left in place and covered, ready to be rebuilt when winter returned. This approach reduced labor and ensured consistency in shelter design across generations. The efficiency of these Ice Age shelters is difficult to overstate. Modern reconstructions demonstrate that interior temperatures could remain dozens of degrees warmer than outside air using only small fires. In some cases, the performance rivals modern emergency shelters built with industrial materials. These survival strategies had a lasting impact on human development. The ability to endure extreme winters allowed humans to expand into new territories, access new resources, and support larger populations. The knowledge required to build and maintain winter shelters had to be passed down accurately, encouraging the development of teaching, communication, and shared cultural practices. Over time, many of these techniques were lost as climates warmed and environments changed. Permanent buildings replaced seasonal shelters, and industrial materials replaced organic systems refined over thousands of years. Yet the principles behind Ice Age engineering remain relevant. Insulation, airflow control, thermal mass, and efficient fuel use are still fundamental to modern building design. When we look at these early shelters, we are not seeing primitive solutions. We are seeing intelligent responses to environmental challenges using the tools available at the time. Ice Age humans were not merely surviving, they were engineers, planners, and innovators who understood how to work with nature rather than against it. Their legacy lives on in every insulated wall, every ventilation system, and every effort to create warmth and safety in harsh conditions. Long before machines existed, humans built systems that allowed them to thrive, and in many ways, those ancient solutions continue to shape how we live today.